Gentlemen, how are you? Good. I'm happy you're awake, because it's not going to get much better. We're going to talk about profiling in Maya, how to make your tools, your scenes, and the other garbage that you've written faster. I don't call it garbage, sorry. I shouldn't say that to customers. So who am I, and why are you listening to me? My name, like I said, is Ravi Jagannathan. Just Ravi at Autodesk.com, because Jagannathan is very long to type. I am a software developer with Autodesk Consulting. My focus is Maya. I work on-site at Sony Pictures ImageWorks. If you've seen any of their movies like The Amazing Spider, who's here, who saw Amazing Spider-Man? Oh, okay. How many of you liked it? Okay, that's good, that's good. Do you guys see Green Lantern? Okay, I'm sorry about that. I really am. So, we have to do a legal non-disclosure agreement. We've seen this all day. Basically, what we're trying to say is we're going to tell you a lot. Don't hold us to what we say. And we have good intentions when we tell you about the things that we're going to do. But you know what they say about the good intentions. The road to hell is paved with good intentions. Luckily for you, I'm Hindu. We don't believe in hell. So why are you here? That picture is basically one of the reasons you're here. Maya is not an application anymore. We've been sitting through lecture after lecture after lecture talking about things like the metadata, the very great lecture on metadata, an amazing lecture on the API. We're talking about newer technologies in Maya. But what does it all mean? Maya is not an application that you simply fire up. Almost every picture in here, this is a visual effects pipeline. An animation pipeline is not much different. Almost every little box in here uses Maya. That means there's a bunch of different artists. There's a bunch of different, what is the word? What's the word that you put on a resume? Skill sets. There's a bunch of different skill sets all at work here. They all have different needs. And it's all being run by one application. So that's one reason you're here. But the real reason you're here is because we're getting more work and we have lesser time to do it in. How many of you saw Alice in Wonderland? All right, that's a few people. Alice in Wonderland was a Tim Burton movie done a few years ago that had a lot of Maya work, as you'd imagine, a lot of special effects as what a Tim Burton movie would have. Green Lantern, the ones that I was apologizing for, had half the deadline and twice the shots. I don't know the exact numbers, but that is the kind of proportion we're talking about. As time goes by, the work that you have to do gets more intense. I don't have to tell you that. And you have lesser and lesser time to do it in. And bigger production companies, almost every production company, but bigger ones in particular, they'll have a lot of lines of code. They'll have a lot of tools written to do all this fancy work that you're talking about. It's thousands of lines of code in the case of Sony. I'm sure that's the same at ILM, at Disney, at DreamWorks, everywhere. And you can't always optimize and shove a new tool in when you have productions going. And you'll often have artists going from one production to another. And there isn't time between them. Sometimes they overlap, and there isn't even time between them to look over your tools and look over things and say, OK, you know, how could we make it better? Well, that's where we can help. And that's what we're going to try and cover in this class. The goal for this class is first to talk about what profiling is and what it isn't. Just kind of draw the lines a little bit. We're going to talk about how to profile MEL code. Maya has been around for more than a decade at this point. Python is a recent introduction. MEL is most of the code bases right now in production are MEL. How do we profile the DG? How do we look at what's slower or bottlenecking in the DG? How to cover Python code, or how to profile Python code. So at the end of this class, if I have done my job right, at the end of this class, you should know how to profile MEL. You should have a good idea about profiling the DG. you should know how to profile Python code, and we'll see what other options there are. If those tools do not give you the answers that you want, there might be other things that do. So what is profiling anyway? Well, the technical definition is using a systematic method to figure out how much time and space a process consumes as it runs. All right? This assumes, and this is where we have to draw the line between profiling and debugging. This assumes that your tool actually works and that it gives you a consistent result time after time after time. So that's where we say profiling is not debugging. It's a type of debugging. You're trying to find a bottleneck, fine, but it's not debugging in the programming sense, where you're trying to find an error in your code, where your program isn't giving the right results. But really, when you think about it, the metaphor is like life. It really is. It's like life. You ever looked in the mirror? Have you ever looked in the mirror and then just said to yourself, Jesus Christ, how did I get here? I used to be faster. I used to remember things better. I used to perform better. And then you take stock in your life, and you think about the things that are slowing you down. You think about what your bottlenecks are, and you get rid of them. And then all of a sudden you find you are performing better. You are remembering things. That's the analogy that I would use for what profiling actually is. So how do you profile? How do we do this? How do we actually, on the broad strokes, how do we figure out what's slow, what's not slow? Well, it should really be done like a science experiment. And what that basically means is you isolate and identify. You figure out a workflow that is actually being a bottleneck. So maybe an artist comes up to you and says, oh, I'm doing this, and it's just so darn slow. Or I'm trying to manipulate something in a scene, and that's slow. Well, that's where you start. And you don't want to look at multiple cases at the same time, because you might get confused. So you isolate to one case or one consistent workflow that is consistently slow. And then you diagnose it. So what are the types of profiling that are there? Well, there's two types. The first one is deterministic profiling. And deterministic profiling is just like the name implies. All right? You're determining where something starts, a process starts. You're determining where it ends. You figure out how much memory is there. You're measuring every single thing. So that means that you can have very precise measurements. It's great. The problem is it can slow things down because you're measuring everything. That can sometimes affect how a program executes. You won't find that happening in Maya too much, but that can be a side effect with deterministic profiling. The other kind is statistical. And statistical is basically you're doing a survey of your process. You are sampling the active instruction pointer, and you're just saying, oh, what's this program doing now? What is it doing now? It's basically asking, what are you doing now? What are you doing now? Constantly. And you can sample at regular intervals. The advantage to this is pretty cool, is that sample programs can run at nearly full speed. Zoom Profiler is a great example of a statistical profiler. The problem is, obviously, depending on what your intervals are, it can be an approximation. That is to say, the results can be an approximation. So this is why they call it a class. We have a quiz. Give me an advantage of each type of profiling methodology. I am not moving to the next slide until I get an answer. You. I pick on him a lot. I'm sorry. Yeah. An advantage. Give me an advantage. That's not an advantage. Oh, Lord. Anyone else? There's more of these, so. No? All right. Well, it doesn't matter. So in deterministic profiling, it's very precise. And with sampling, statistical, you can have your programs running at full speed. That kind of stuff, well, it matters at some point. What's Maya made of? So we're talking about profiling. We've talked about what it is. We've talked about what types there are. Well, what can we actually measure in Maya? What are its building blocks? Why do we care so much? And Maya, broadly speaking, is built like this. It's got a command engine and a dependency graph. So those are the two main components. And the command engine basically has MEL and Python in it. They're both built differently. MEL is they both integrate into Maya differently, I should say. MEL is it's a simpler Lex-based language, I think, and Python is Python. Python's a great language. And then we have the dependency graph. I won't bore you onto how the DG works. And then we have other things that build upon these two and use the API. You have translators, manipulators, etc. So what are the tools that we have available in Maya that you can profile with? Well, the first one for MEL code is the MEL Profiler. Yay. Python comes with its own profiler, which is why we didn't have to write one. It's called cprofile. There is the DG timer, which has been around for a long time. It's a wonderful command tool. And the DG profiler, which is just a UI that sits on top and uses the DG timer API to display things using a UI. So let's talk about the MEL Profiler. He's no longer with ImageWorks, by the way, but that's a great quote when we had created it. This was actually a tool that was created for Sony Pictures, and I got this quote from the guy who used it initially, so he was really happy. So how does it work? Well, this is basically how MEL works, this left piece here. MEL code gets interpreted, and Maya executes it, and then your code finishes execution. Well, this, if you're doing a deterministic profiler, which is what the MEL profiler is, the code, when it starts here, we measure that. So we say, all right, we get all this information, we shove it into a call stack, and we start our timer. That same code, when it finishes, we record the times, we get the call stack information, we push it on. That's actually should have been pop. That tells you I was lazy that day. But that should be pop. That's a mistake, and that'll be fixed before it gets uploaded. And it uses a callback in the API, which is new to Maya 2013, but it was available to others via consulting. And this is, it's something called add proc callback. I shouldn't say something called, I wrote it. But basically, the way this callback works is a little different. It's a straight function pointer right into MEL. It's not your standard callback in the Maya API. It might look like it. And the reason we did that was because the callback mechanism in Maya API was a little slow. So the way a standard callback mechanism works, it's kind of like a lecture. You have a server just pointing information. This is a straight function pointer, and it actually gives you a tremendous speed up. The disadvantage is that you can only register one callback at a time. And the MEL profiler just records this information here. You can record the command name or the proc name, the number of calls, the amount of time. It's called self time, the amount of time that one procedure took, and the average call time. And we also, it's called total time here. It's also called inclusive time, which is if proc A calls B, then the total time for A is the time that is the self time that A took and added to the self time that B took. Yeah, I think that's right. So how is it used? It's pretty simple. You just load the MEL Profiler plugin. You can fire up the tool. It's in the command menu in the script editor. And you just say start profiling on the menu there. You do your workflow, you stop profiling, and you play with the data that you get. It's pretty simple. It was built for simplicity in that respect. This is what it looks like. Behold, 2 weeks of work. And it's using the spreadsheet widget in the API. Unfortunately, that widget is not entirely complete, so you can't sort by the columns. But like I said before, it's pretty simple. You can start your profiling. You can stop it. You can save your profile data as a CSV file so that you can analyze it in Excel or Open Office. And you can save the call graph data as a dot file. So this is what it looks like if you want to do more sophisticated analysis on your data that you get out. If you want to sort by, say, self-time or average time. And this is a call graph. So let me just go back here a second. What you're looking at here is basically a profile of the Maya plugin manager. So when the plugin manager starts up, you can see that items here are highlighted. So this is, if it's more than 25% but less than 50%, it gets this color. If it's more than 50%, it'll get red. And if it is below, if it's between 10 and 25%, it gets a slightly lighter version of that. I don't know what that color would be. Because this is yellow, I don't know what that other one would be. And that is typically reflected in the dot graph. Dot is a language for representing graph data. So if you want to see how something calls something else, you can use dot. And you can see here that here you have a proc, or procedure. It's calling something else. And this is the number of times it calls it. And you can see that there's a lot of calls in here that are in the several hundreds for the plugin manager. So what kind of stuff would you be looking for with all that? Well, with the spreadsheet view, this guy here and this guy, well, it highlights the rows for you. So you can actually see, OK, what's slow, what's not. This is basically saying what I had said before. And then you have your call graph. And the call graph is great because it helps you analyze the flow of your program. So we had this at ImageWorks at one point where they have an auditing callback. And what that thing does is, anytime an artist does something on a rig, that's recorded on some node. You're under NDA, by the way. I'm not sure how much of that I should have said. Anyway, they used the MEL Profiler to actually analyze all of that, and they found that in the call graph, so they didn't necessarily see it in the spreadsheet view, but in the call graph, they could see one call being made hundreds and hundreds of times. And all that had happened was a file load. And they fixed that. I mean, there are other cases where they've used it. You'll see it in a second. But they fixed that, and file loading time had actually decreased quite a bit. So again, does that flow make sense? And related to that use case, do some operations need to be called whatever times? What don't we measure? Unfortunately, we don't measure memory usage, which is something that we really need to fix for the next version. The profiler does not measure the amount of memory consumed, which would have been great in being able to catch memory leaks and stuff like that. But you can monitor it with third-party tools. On Linux, GNOME System Monitor does a really good job of catching it. It comes with the operating system. On Windows, there is the Performance Monitor, which is also really good at catching memory leaks. And I don't have a better word for this. It's called aggregate bottlenecks. So you'll have a situation where you write something, and the individual pieces are fast on their own. But in some scenarios, you call them together, one after the other, and it's really slow. A great example for this is actually the plugin manager. In Maya, the first time you start up the plugin manager, it is obscenely slow because it's doing disk reads. It's doing constant disk reads. You start it up again, and it's faster because that data has been cached by the file system. And so who's actually used this? Well, there's a small company called Autodesk that used it. And this was actually a very interesting case. I didn't even know that. I had just checked in the tool, and the next day, someone had emailed me saying that they'd used it. And this is that use case. When we were building Maya 2013, we were diagnosing the interop between Motion Builder and Maya. And they'd found one slowdown that was slowing down sending rather information between the two packages, and that had been because they had done updates to the UI with every update from Motion Builder. And if you ever use Motion Builder, it's a real-time application. It sends out a lot of information. So obviously, that's one of those things that's obvious in hindsight. It's not always obvious when you're building the tool. They removed it, and the workflow sped up. I was told it was sped up by a factor of 2. I'm betting it was a lot more. And who else has used it? Well, the customer who requested it was the one who also actually used it. And Sony had, this is actually, there are many examples, but this is actually the best one. I'm very fond of this one. What had happened was Sony has a lot of hair tools for effects. They're an award, they actually won awards for their tools for this. And what had happened was that they were trying to get control hairs on one side reflected on the other side. And that sometimes took a very long time. It took up to an hour in some cases. So they analyzed the problem with the tool. And again, a solution that was obvious in hindsight, cached the geometry, but it sped things up. It sped things up by a lot. I mean, it went from 45 minutes. So that's basically a lunch hour for an artist. It sped it up to 2 seconds. You know, you've gone from a lunch break to the blink of an eye. Well, I don't know. The first quiz didn't go so well. So have I put you to sleep yet? What language is used to describe the call graph? Ah, dang it, they were paying attention. I was hoping to spend more time on that slide. All right. So that covers MEL. What about DG Timer and the profiler and DG Profiler? Well, again, the profiling tool is a deterministic one. DG Timer has event-level timing mechanisms on nodes in Maya. So every event that happens in the DG gets measured for time. So obviously, you have your dirty propagation, you have your compute, and the fetch, which is basically you do a get at and pull values from a plug, and that's what is called fetch. And the DG Profiler is a plugin that uses the same timing mechanism. The DG Timer timing mechanism is in the Maya API. It's, I think it's been in there since Maya 2009, but it's using, well, MFN dependency node has the DG Timer method. So again, it gets a lot of stuff. You get the node name, you get the percentage of runtime. So your DG, your scene has taken a certain amount of time. Let's say you're doing a playback or something. So how much did one node take as a percentage of that? What was that node type? And the compute self-time. So just how long that node took. So let me just go back here. The self-time for a node's compute here is just how long this node took to compute. The inclusive time would be this node plus this node. Well, it should be the other way around. And again, it's just like the MEL Profiler. You load the plugin, you launch the tool, and this time it's under the window menu, the general editors submenu, and you run it the same way. DG Timer, this is a command that's been built into Maya. It's extremely well documented. There's actually been a lot of improvements to it, and it's pretty easy to use. And this is what the DG Profiler looks like. And it's a little different from the MEL Profiler based on feedback from the users who had used it. And again, it's a spreadsheet widget. And this, in this particular instance, the numbers that you're looking at here, this was profiling a cloth sim. So it's a basic cloth sim, a sphere moving a nucleus object around. And again, it's pretty simple. You can filter by the node type. You can highlight entries. So as opposed to the MEL Profiler that automatically highlights entries for you, the DG Profiler just lets you figure out what kind of entries you're looking for. And it lets you comb through things a little more finely. And you can set the number of runs you want. So you can say, you know, I want you to play a scene 20 times, and then it'll report the numbers. So what kind of things should you be looking for with the DG Profiler? And like I said before, you can do a lot of extensive combing with it. You can do you can filter by node type. You can filter by percentages. You can also graph them and use the heat map functionality in the hypergraph, which is in the UI. And it's great for catching spot improvements. And spot improvements means what exactly was the one thing that was slowing things down. So obviously, in a nucleus sim, the solver is going to take a long time. And you can quote unquote, fix that bottleneck by caching it. Again, what can't be done is memory usage. And this is, again, something that we have to, at some point, fix. The DG, or anyone's nodes in particular, can sometimes take up a tremendous amount of memory. And more than just the node, the data going back and forth across a connection. If the plug is cached, how much data do you copy? And sometimes things like that you need to see, especially with rig profiling. And the other thing that the DG does not catch, and we actually had this problem on Superman Returns, but DG Timer was actually really good at catching this, is something called critical chains. And a critical chain is basically you have a bunch of nodes stuck together doing some kind of evaluation, a chain of deformers, for example. The problem on Superman Returns was, and I apologize for that one as well, the problem with Superman Returns was the character was being deformed, and it was a custom deformer. The artist had laid out a chain of them, and it was very slow. It was much slower than what they had expected. So they ran DG Timer on it and found that it was doing about 2 to 3 computes per frame. That's one of the things that DG Timer outputs. It'll tell you how many computes you were doing. So the person who was analyzing this took one frame of the scene that the artist was complaining about and analyzed the output. And we saw that it was evaluating unnecessarily. So that was fixed by using the API as well as caching plugs. So what they had done was they had cached the plugs in the deformer chain, and instead of using the input value method on mData handle, they used the output value. Because your data is going to be up to date in a deformer chain, you don't need to trigger an evaluation up the stream. Again, it's one of those things that's obvious in hindsight, but not when you're actually building it. And who else has used this? What's left of them had actually used this. I didn't know this. I had received a couple of questions about the tool, and then they told me that this is what they had actually been using it for. And with DD, at the time, what they do is they evolve their rigs. So they take the things that worked best on prior shows, and they merge them in with newer rigs that they're working. So take what's best and put it in whatever they're working on. And at some point, they had found that their rigs were performing really slowly. They used the profiler, and I don't say this on here, but what they had done was they had just output a spreadsheet from the DG Profiler, and they analyzed that, and they found that in the fingers, they had IK handles that they didn't really need. They got rid of those because they were a luxury anyway, and they sped things up. So again, it's about a 2 times increase. Well, who else has used this? This is actually an interesting thing, and there's a white paper that accompanies this presentation. The UI that I'm going to talk about here is shown over there. DG Timer has a trace functionality. So the trace functionality is this thing where anything you do, the output from DG Timer times each and every single operation, and it comes out like an actual trace. And what's wonderful about that is it also lets you see the call stack. So you can actually see the evaluation chain. You can actually organize things by like a stack. And you can drill down quite a bit. So they had a UI that would read that output. And they had something that was, this is kind of a meta-analysis. They have a tool that performs a rig analysis. That tool analyzes the rig by evaluating different things on it. They found, again, that things were a little slow. They used the trace output from DG Timer, and they spotted that they were evaluating unnecessarily. They were evaluating FK and IK at the same time. So that was something that they could fix. And they don't say it here, what the speed up was. You know, this was a good idea at the time. But, well, it's a deterministic profiler. That's what DG Timer is. Save you some of the trouble. So what about Python? With Python, we didn't actually have to do too much work. It comes with its own profiler. Python comes with its own tool. That's an anaconda. That's a prop from the movie, which I have. The profiler that ships with Python is a deterministic profiler called cProfile, and it's pretty easy to use. And there's a great video online by Mike Fletcher, and he talks about how to use this, the profiler in Python. He also talks about his own thing called run, snake, run. But again, it includes the number of calls, your self time, your inclusive time, and it comes with its own analysis mechanism, which is a command line one called pstats. So this is just how to use it. This is a function that does Fibonacci. Just import it, and bam, run it. So what else is there? Sometimes, like I said, with memory and stuff like that, you're not always going to get the information that you want from something like the MEL Profiler, DG Profiler, or even DG Timer. So you can use something like Zoom. And we've had companies use it and point out bugs in our code, particularly some of our, oh, can I talk about that? Yeah, anyway, image plane code. It's really fast, by the way. And it's, Zoom is probably one of the better ones out there. And it just grabs all your, again, the information for your profile run. This is not a Maya run, by the way. That would probably be violating some kind of agreement. This is GIMP, so you're not looking at Maya code here. But it captures and allows you to drill down all the back traces and everything that your program, the program that you're profiling, is actually executing. So that's pretty useful. It's great for plugins. It's not so great if you're trying to figure out what exactly Maya is doing, because not everyone's going to have Maya source. But it's still pretty useful. It still gives you a lot of information. And some final thoughts. The crux of all of this is build things to work first, and then worry about how fast it is. Don Knuth was the one who had said premature optimization is the root of all evil. It'll leave you with, the reason it's evil is because it will leave you with an architecture that makes no sense. If you're designing something thinking it's going to be fast, you're only thinking about one scenario in your head. You're not thinking about how the tools are actually going to be used. And sometimes the findings will surprise you, but usually they'll be obvious in hindsight. Every use case presented here, every use case that I've talked about here, it's the same thing. You know, especially with the Sony one, with the hair tool, people are like, oh, of course, we should have been caching the geometry. Well, you know, the guy who wrote it at the time may have been facing a deadline. You know, don't be too hard on the person who wrote it. That might even be you. And that is it. If you have any questions, let me know. And yes, he came first. Yes, sir. Yeah. So if something halts the execution, so something halts your compute, okay, and you haven't crashed the program, you've just stopped computing? No, it should handle that. It should handle that. It'll recognize that compute is finished, and well, I don't know of any nodes in Maya that toss an exception that kill that without killing the program. But if it's in a plugin, at some point it'll hit Maya, and it'll hit the Maya base class and say, oh, I've stopped computing. And that's when the timer will be hit. Yeah. Right. 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 So the answer to that, I don't know how many people heard that question. That was a very good question. The question was, what happens in the case of a nested plug hierarchy? And the answer to that is the UI won't show it. DG timer in its summary will not show it. The trace option on the DG timer command will, because it'll say, okay, there was a compute. It was triggered by so-and-so plug on so-and-so node, and it'll give you the self and inclusive time for that. Yes, sir. Yes, sir. Yeah. Well, yes. The short answer is yes. Right. So yeah, DG. Yeah, and that's available in 2013. I'm sorry. It's using some API changes with DG. With the DG profiler, there was some refactoring of the API in order to implement it, but it's nothing that your ILM has. And in fact, I think I did this. I ported it to ILM's 2012 cut. So, yeah. So what's next? One of the things that right, so for DG profiling, one of the things that we've received as feedback from multiple people is that you want, the basic thing is, it's very easy to, when you design something, to know what you don't want, right? So I had, like a dot graph with the MEL profiler, I was thinking, why not a dot graph with the DG? You can see all the operations visually. Problem is that there's millions of operations and stuff like that. What you really want is something that you can drill down and say, this took a lot of time. So that's the goal. So what's coming next is something that can analyze everything that has happened with a workflow. So not just your DG stuff, but also your MEL stuff, and drill down into seeing, okay, what took the most time. If you have suggestions, you know my name, Ravi, so just email me. And you know, we're always looking for them, for what you'd like to see. My goal is to have something like Zoom. So if you've seen the Zoom UI, oh, right there. So my goal is to have something like this, where you have a stack, and you can order it, and you can see all the stuff that has happened, and then you can click on something and say, okay, this is the chain of events that it took. And these are all color-coded by what took a long time, or what took X amount of time. I mean, that is kind of the goal to have, you know. But ultimately, it's whether or not a client finds that useful. DG Timer is something that has been around for almost as long as Maya has been. And there are people who still say that it's hard to use or it doesn't tell them what they want. It gives everything. It's a wonderful tool, but does it tell you everything that you want? And that's kind of what we're trying to figure out. That's what I meant when I said, you know, when we wrote this, it's easy to know what you don't want. If DG Timer was perfect, I wouldn't need to have written the DG Profiler. You know, what do people want? That's the kind of thing. I don't know if that answers your question. I'm sorry if that's... Kind of? Right. Yeah. Yeah, I think that's a good idea, sir. Oh, yes, sir.
2 things. Are you going to be around tomorrow at home?
Oh, yeah, that's the other thing I wanted to say. I am going to make myself available for the Dev Lab tomorrow, so I'm more than happy to show this. And if you guys want to poke holes at it or ask me how it works and stuff like that, I'll be more than happy to show you and listen. One thing is, let's go back. Jeez. Yeah, a lot of slides. Please, 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 if you have a suggestion, if you have a comment, make sure to email me. Make sure, like, I will read it. I may not respond to you, but I swear on my various gods, we'll read it. You know, let me know. Yes, sir.
Well, a point of feedback in that case is we have submitted numerous issues about, you know, opposition issues regarding Maya, and unless we push them like to the very top of the most important issues, it doesn't seem that many of them are addressed very quickly.
Well, maybe they're all here doing presentations.
Yeah.
The only answer I can give to that is these tools were written because a customer wanted them. I mean, especially with the MEL Profiler, the budget was, I think, 1 day to spend and write it. It took 2 weeks of all my nights. My wife was very upset. I spent 2 weeks of nights constantly and weekends writing that tool. And that was because a customer was saying, you know, it's so darn slow. All the tools that they've written were performing slowly. If it was just one tool, okay, fine, you can assume it has some problem with that. But we do listen. You know, there's a lot of us who are motivated. We do listen. And if you have an issue, email me directly. And, you know, especially with instrumentation, we can try and figure out what's going on. Now, you're with Disney, right? Okay. If you want to know how to use the Zoom profiler with Maya, that's the guy to ask. All right? Now, your guys are very, very good and proactive in that respect, right? And that's something that we need more of. And that is how I figure out, you know, that's how, when I talk about getting feedback, that's the kind of thing we talk about. Jay, God, I should remember his name. Thank you. Sheesh. I complain about people not remembering my name. But Jay Steele, guy is very proactive. He tells me exactly the kind of things he wants. And sometimes with information like that, there's a lot of it, and it'll get addressed. It may not get addressed as fast as you'd like, but it's not like we're not listening.
What are some of the most recent things that were added to the timer? Because I know it was missing good chunks of, like, dirty propagation. It was only giving you half the story and things like that.
Well, the timing mechanism was, a lot of it was improved. Improved is the wrong word. It became more complete, I think, in a few years ago. So there was a concerted effort driven by a consulting client, probably you guys, that got more improvements in it. And also the API was added around that time. So that's the API. It was new, I think, as of Maya 8.5, the DG Timer API. And then for 2013's release, we changed a couple of things. Just some minor refactoring on that end. That it? Yes, sir. I'm sorry? Yeah, okay. No, I had a point in the last slide. Okay, so the genie joke, this is what got me married. All right, this is the joke that got me married. I am of Indian birth. I had an arranged marriage. And when my wife and I decided, all right, we were going to get married, we had to introduce each other to our parents. My wife, being the person she is, impressed my parents to no end. My mother said, marry this girl or I'm killing you. You know, I had to impress the girl's mother. And my wife, meeting the parents under any circumstance for the first time, it's a very nerve-wracking experience. I mean, you think standing here giving a presentation is hard. It's harder to meet the parents of a girl you're going to marry. My wife said basically, oh no, he's actually a really funny guy. And then she looks at me and says, tell a joke. I was on the spot. So I started, and this is what I said. This is what I said, and this is what my mother-in-law really appreciated at the end. This husband and wife, they're in a field, and they're just playing with the ball, right? They're just a standard baseball. They're tossing it around. A husband, he decides to be a bit of a jerk. He tosses the ball too hard. The wife ducks it, and the ball sails off in the distance. And in the distance, they hear a window crashing. The husband has obviously broken a window. So they go in the direction, and sure enough, they see a house with a broken window pane. They knock the door, and they find it's unlocked. They hear a voice, come in. They go in. They see an old man sitting on a rocking chair, and he's just looking at them. There's pieces of broken glass on the floor, the baseball, and pieces of a broken lamp. The husband's obviously broken the lamp as well. And they're very apologetic. The husband and wife say, you know, look, I'm very sorry. We're very sorry. We'll pay for the lamp. We'll pay for the window pane. And the old man looks at them, and he says, you know, I should actually be thanking you. You see, I'm a genie, and I've been stuck in that horrible lamp for thousands of years. And I am now finally free. And husband and wife are like, okay, you know, they're kind of surprised. And then he says, look, I will give you 3 wishes. I will give you 3 wishes, and then I want something in return. And the husband and wife are like, wow, this is awesome. Okay. And the first thing they wish for, they want a lot of money. And the genie snaps his fingers and says, all right, you each have $1 million in your bank accounts. And then they say, we want eternal youth. He snaps his fingers and says, I can't give you eternal youth, but you will be young and vital till the end of your days. Great. Then they say, we want a great house. Genie snaps his fingers and says, all right, you now have a wonderful palatial estate on your own island. The husband and wife think, wow, this is awesome. We're set. Then the wife asks the genie, what do you want? And the genie looks up and says, you know, I've been stuck in that lamp, like I said, for so long. It got very lonely in there. And he looks at the husband and says, I want you for a few hours. And at this point, when I'm telling the story, when I get to this line, my mother-in-law, my future mother-in-law, her face goes from to, And she's like, where is this going? I don't think I want to hear the rest of this. And I can tell she's starting to seethe. But, I've started telling this. I've got to finish it, right? So the husband and wife, it's like they've gone deaf. They're like, what? And the genie says, no, I'm serious. I felt very lonely. And he looks at the husband again and says, I want you for a few hours. And the husband and wife are like, no, we can't do this. They're talking to each other. And the wife says, I've got some serious misgivings about this. And the husband is quiet for a little bit. And then he says, I didn't like it initially. But we're set for life now. We have our home, we have money, we have youth. I'll take one for the team. I'll do what he wants. And the wife is understandably a little upset, but she says, all right, fine. And they say, all right, fine. They tell the genie, okay, we accept your offer. Genie takes the husband upstairs. And after a few hours, they're both in bed, naked. Genie's smoking a cigarette. He's looking very satisfied with himself. And he asks the husband, how old are you? And the husband is very embarrassed, after considering what he's been through. And the husband says, I'm 45 years old. And the genie nods, smokes a cigarette, and he says, really? You're 45 years old and you believe in genies? Thank you.